Hello students, welcome to rdchemistry. Please do subscribe rdchemistry, like the videos, share the videos and please write the comments. In this video, I am going to explain second mechanism, that is the SN1 mechanism under nucleophilic substitution reactions. You know that there are two types of mechanism. One is known as the SN1 mechanism and other one is the SN2 mechanism, correct? What is the meaning of SN? SN stands for substitution nucleophilic. Substitution nucleophilic, correct? One stands for unimolecular, correct? Unimolecular. Now, what do you mean 2 stand for here? It is known as the bimolecular. Bimolecular. Bimolecular, correct? Bimolecular means there are two reactants involved in the slowest step, correct? Which I explained in the last video. Now in this video, I am going to explain SN1 mechanism, okay? So it is a unimolecular, only one molecule is involved in the slowest step, okay? Now what is the example for this? Example is reaction between tertiary butyl bromide and hydroxide ion gives a tertiary butyl alcohol. Let me write down the reaction. Let this carbon be the tertiary carbon. To the tertiary carbon we have got the Br. Okay. And when you say it is a tertiary carbon, this should be attached to the 3 more carbon atoms directly. Correct. So this becomes tertiary butyl bromide. Altogether 4 carbon atoms are there. Remaining valence is by hydrogen, correct? CH3, CH3. Clear? Plus hydroxide ion, OH minus. Hydroxide is with the either sodium hydroxide or potassium hydroxide. Okay? To give, our target is to remove this halide ion. Okay? To give carbon attached to the OH. Okay? And then CH3, then CH3 and then CH3. Br atom, halogen is a leaving group. So it becomes Br minus bromide ion, halide ion. So this is the alcohol now. This alcohol is called as the tertiary butyl alcohol. This reaction can also be written like this. We have got CH3 repeating 3 times. Attach the same carbon. Then there is a Br. Then you can write OH minus to give tertiary butyl alcohol, CH3 thrice on the same carbon atom, OH and plus Br minus. Remember students, in the previous case SN2 mechanism, okay, OH minus nucleophile supposed to attack from the back side, but here in this case backside attack is not possible because the CH3 groups are little bulky groups. Say carbon atomic mass is 12, 3 hydrogens are there, 15, correct? So 15 here, 15 here, 15 here becomes bulkier, okay? So there is a steric hindrance, overcrowding of the atom. And also OH minus cannot attack from the front side also because of bromine atom mass is approximately 80. Now what is the atomic masses? Okay, or molar mass of the hydroxide? 16 for oxygen and 1 for hydrogen becomes 17. Okay, therefore 80 little bulkier and 15 plus 15 plus 15 also little bulkier, and so there is no front side attack, there is no back side attack. That's why I taken SN2 mechanism first. Okay, now but there should be a reaction now. Now what is the reaction taking place? So that we are going to study in terms of SN1 mechanism. This mechanism involves 2 steps. In the first step, ionization of tertiary butyl bromide to give carbocation. So let me write the structure of tertiary butyl bromide. Carbon attached to the Br, and this carbon is a tertiary butyl. Okay, tertiary carbon atom. So this is the structure of tertiary butyl bromide. Now what will happen? There is no backside attack, there is no front side attack. But now what will happen? Ionization. So this carbon bromine bond, covalent bond, it will undergo ionization. When I say ionization, give cation and anion. Okay. So but breaking this bond is not that easy because it's a covalent bond, stronger bond, sigma bond. Therefore first step is the slow step. Okay, and this is known as the RDS. What is RDS? Rate determining step. which we will studying in chemical kinetics. Okay, so what will happen now? Carbon loses its bond because the bond goes along the bromide ion, because the bromine atom is more electronegative compared to the carbon atom, correct? So because carbon bromine bond is a polar bond, so we'll get Br minus, therefore carbon gets positive charge, shortage of bond plus. Okay, so then CH3 attached to the carbon atom, so I'll be writing like this. Okay, so this forms a triangular shape. Okay, this forms triangular shape. This is because this carbon atom, which is positively charged, is a sp2 hybridized. Carbon carrying positive charge is called as the carbocation. This carbocation is a sp2 hybridized. And here the carbon atom which is attached to 4 bond, it is a sp3 hybridized tetrahedral. Okay. In the second step, OH minor, that is the nucleophile, attacks the carbocation to form the final product. So we have got carbon attached to the three CH3 groups. Okay, and this carbon atom is positively charged. So carbon plus cation, carbocation. It reacts to the hydroxide and easily attacks. Okay, so now this is the reactive species because the shortage of bond, shortage of electron, easily attacked by the hydroxide to give the final product. Okay, to give tertiary butyl alcohol. Correct. So it gives a tertiary butyl alcohol. OH should be there. Correct. OH. Clear. And reaction between positive center and negative center is a very fast, very easy. So it is a first step. So the first step. Clear. Right. Now the rate of the reaction, you know that it depends on the slow step. Which is a slow step? First step is a slow step. Therefore, rate is equal to, according to chemical kinetics, rate is equal to always rate constant K into concentration of the reactant in the first step. Reactant is which one? CH3 thrice CBr. I'll write together, or alkyl halide in general, to the power 1. One molecule is there. So therefore order is equal to is the power of the concentration term 1. Therefore order of the reaction is equal to 1. Since order is equal to 1, only one molecule is involved. So it is called as the unimolecular reaction. Unimolecular reaction, or we write it as the SN1, substitution nucleophilic, and it is unimolecular. And this reaction required a solvent. Now what kind of solvent required? To facilitate this ionization, we require polar protic solvent. Remember, polar protic solvent. When a polar protic solvent is there, reaction becomes faster. Remember, what are the example for polar protic solvent? Water H2O or ethyl alcohol C2H5OH. Clear? Right? This you have to remember. Okay. Now, which type of alkyl halide easily undergoes reaction by the nucleophilic substitution by SN1 mechanism? It is the tertiary butyl alcohol, because tertiary butyl alcohol can easily form the carbocation. Tertiary carbocation more stable compared to secondary carbocation compared to primary carbocation. Therefore, bulkier molecules prefer to undergo SN1 mechanism. Smaller molecule undergo the SN2 mechanism. Okay, clear? Now, what are the differences between SN1 and SN2 mechanism? For SN1 mechanism, the reactivity of alkyl halides are tertiary greater than, secondary greater than primary alkyl halide. Whereas for SN2 mechanism, primary alkyl halide is highly reactive, then secondary, then tertiary. In case of SN1 mechanism, protic solvent is required for solvation, whereas in the case of SN2 mechanism, protic solvent is not required. Okay. The next difference is, under SN1, reaction rate depends only on alkyl halide. Concentration of alkyl halide depends on concentration of alkyl halide. In the case of SN2 mechanism, reaction rate depends on concentration of both alkyl halide and the nucleophile, and this is depending on the slow step. For SN1 mechanism, order of the reaction is 1, whereas for SN2 mechanism, order of the reaction is equal to 2. Like the videos, share the video, subscribe and support me. Thank you for watching.